This video covers Chapter 8 of your textbook, which is about characters and strings. You will find that a lot of the functions that this chapter talks about have already been introduced to you in previous chapters, partly by me, rather than it being a formal chapter. But we'll learn some new things in this chapter. So the first section we're going to talk about is different functions that you have available to you when you do an include ctype.h in your file. Oops, right there. And these are basically character handling functions, many of which you have already seen. And here's my little cartoon about character. It's kind of interesting if you've ever heard of the Myers-Briggs test. It has 16 different personality types, character types, but that's my little humor for this. Oh well, moving on. This is a chart from your book that shows a bunch of the functions that you have available to you in the C-type library, which is character handling functions. The ones that I have put a red circle around are ones that are different functions that return true or false. So it's a test of some type. It's going to do a test on a character. And this chart is showing the function prototypes for each of these functions. This is useful information because you want to know not only the name of the function, but what is its return type going to be and what type of parameter is it expecting. So for example, int is blank is expecting to have a character passed to it, and it's going to return an int once you've called this function. Most of these functions are pretty self-explanatory. Your book has a very long example going through each one of these and demoing how it works, but they're really quite self-explanatory. So is blank returns true if the thing that you've passed to the function is a blank character, and it returns false otherwise. So let's see, there's some other ones. There's two upper is not one that returns true or false. It changes a lowercase letter to an uppercase letter. You already saw that in a demo that I did in a video last week. So these are a bunch of character tests. Here's some more character tests. But before I demonstrate a little bit of these functions, I want to talk a little bit about the fact that it says it returns true if the test is true, and returns 0 false otherwise. But it says returns true, yet each one of these functions returns an int. So what does it exactly mean? Well, let's look at this example first. Well, false returns a 0, it said so, but true, what does true return? The function says it's returning an int, so true actually returns a non-zero int. And I said, a non-zero int, what is that? I always thought that was 1, but it turns out that it's not necessarily a 1. So I'm going to use this function as an example that is alpha. But before I do that, I have two print statements here for you just to show you what returning true and returning false could be. So here I do just a test. 5 equals 6. Well, that's a false statement, and I'm saying print the result of this operation right here, which is false, but it's not going to return the word false. It's actually going to return an integer value indicating it's false. And when I run that command, it will return a 0. So the printf is going to print a 0. The next line, I make this a true statement, and I wanted to see what would happen if some test evaluated to true, and it will return an int, a non-zero int to indicate true, and in this case it returned a 1. Then I tested the isAlpha function. The argument I passed to it was the character h, and h is definitely a character, so that's a true statement. And it turned out when I did this printf statement, isAlpha returned 2, which is a non-zero int. You can pretty much try out all of the functions that are listed here in the character handling library functions. you can pretty much try them all out with a statement such as this, and you can test what constitutes a true or false. So your book did that. It's a bit of a wordy example in a way, but I will show you, bring it up here for just a moment anyway. So this is the example that your textbook uses. It actually goes through, does 2 tests to see is digit, and it just tests it with this type of a statement. And then there's a rather long format specifier right here, and I'll show you the results in a moment. And then it goes through the is alpha, is a number, is a digit, and so then there's some results. I'm not going to walk through an example of each one of these functions. They really are self-explanatory. A is a letter, B is a letter, ampersand is not a letter, 4 is not a letter. It's really self-explanatory. The one that's a little bit new is X digit. So X is for hexadecimal. So it's asking, is a digit a hex digit? So F is a hexadecimal digit, but J is not a hexadecimal digit. And the results are kind of as you would expect them to be. So moving on. So that was the character handling library, C-type. You can look at all of the different functions for C-type. Let's move on to things that you can do with strings of characters or arrays of characters. But before I do that, I want to preface it a little bit. Here's how you would declare a string. C doesn't have a data type called a string. C only has a data type that's a character, but you can make an array of characters, which is what I've done here. And so that essentially makes a string, but don't forget there is a hidden /0 escape sequence at the end of this string. So I wrote that there. Now this string of characters, these characters are not stored literally on your computer. They are converted using the ASCII code into, actually they're encoded in some binary, encoded in ASCII into a binary number and stored in your computer. But there's little programs that you can just Google them, and you can convert any string of character string you want. You can convert it and you can see what it looks like in the hexadecimal. So this was from a ASCIIvalue.com website. I entered my phrase, it converted it to the corresponding numeric values that are stored in your computer. This becomes important when we use some of our string functions. A few more words about declaring strings before we talk about the string functions. I said one of them, here I declared message. Here's another one I declared a string array of characters called color, but I can also put a pointer to it with the next line of code that I have. So this points to the string blue that's somewhere in ROM, meaning read-only memory. And then I can print, here's with the string format specifier, I can print p color and it will print the word blue. I can also do this, print p color, and that points to blue, so it will also point out blue. So that was sort of a review of strings and pointers. Remember, the beginning of a string, the address at the beginning of the string is the address of the array. So now let's look at some string functions that are included in your standard library.h library. So if you do include stdlib.h at the top of your program, you can have access to these string functions. I will honestly have to say I have never used these string functions, but nevertheless I will show them to you. They're a little different. I'm going to do the first one. The second two are sort of similar. The first one will explain what's happening, and you'll get the second two. When you read the example in your textbook, you really have to read it slowly and carefully and kind of figure out what's going on with this function. So I'm going to do my example. Actually, very similar to your book's. It is your book's example, but I'm pointing out a few things. So I did include standard library, so I get access to this string function. This is the function prototype for this string function. So I'm going to have to pass an address that points to an address that of an array of a character string, and I'm going to have to pass, and here's that double. This is also an address, but it's called somewhat an arbitrary name. It'll make sense in a moment. It's called the end pointer. So this is what's going to happen to the second part of our phrase. So let me show you what it's doing. So I made a string right here. 51.2% are admitted. That's my string. And I made a pointer. Now this string pointer is not related to the string pointer that I made right above. These are two different pointers right here, and I think that could be the point of confusion. So I know string to double. This is string to double is the name of this function. String to double is going to return a double. But what it actually is going to do is going to go through this string right here, find the things that aren't characters, that are numbers, and it's going to convert it to a double value number, and then it's going to take the rest of the string and stick it in this second address right here. So I'm calling the function string to double. I passed a string, which is this whole phrase, into the function, and also I give it an address right here. And this is what happens. This is the end result. Double is returned. So the actual thing that's returned is a 51.20. And I use this format specifier to make it be 2 digits past the decimal. Remember, up here, 51.2 is a string. It's not recognized as a number. But this function will recognize it as a return number and sift it off and return an actual double value. So that's where where the function is useful. If you were parsing through a string that had numbers in it, the string would be considered totally a string. Even the numbers would be a string. But this function will find those digits and convert them to a double value. So it returns, the function returns, so D will get this value 51.20. And then this second thing right here says everything after that number, which is %R admitted, gets stored at this new location, this new address. So %R admitted gets stored at a new address. That's what this string function does. And the other two are sort of similar. You can see their subtleties. The next set of string functions, or functions related to strings or character strings, comes from the standard I/O library, which we're already using and which you've been using since day one. Because why? The keyboard is our standard input device that goes to our program. The display is our standard out, and there's something that we can also get, standard errors, as we're going to talk about here a little later in the video. And we get all of this through a text terminal, so that's my little graphic. So let's talk about what functions we can get with standard I/O that we haven't already talked about. By the way, going back, what's another function that we get from standard lib from a different chapter? The rand function also is in standard lib. But anyway, let's go on. So we're going to look at some new functions that are in standard I/O. Some of these we've seen before. Get character we've seen. Puts we've seen. Scanf we've seen, but this is an scanf, so there's a slight difference with that. And then there's some new ones that we haven't seen. Fgets, put character, put char, which is probably pretty obvious. And this sprintf we've also not seen yet. We've seen printf, but not sprintf. So it says that sprintf is equivalent to printf, except the output is stored in an array S instead of printed on the screen. Scanf is equivalent to scanf, except the input is read from the array S rather than from the keyboard. So I'm going to demo those two. These scanf and sprintf are going to be useful for file operations. we do file operations in this chapter or the next? Well, we'll see. So these are pretty straightforward. Let's show examples. So the first example is actually 810 in your book. I'm going to demonstrate puts and fgets, but we already know puts. Puts just puts a line of text followed by a new line onto the screen. So here's the use of fgets. And I have three arguments being passed to it. A sentence, a size, so fgets you have to say how many spaces for an array you're allowed to get, and then using the standard in. So when I do this program, I'll just demonstrate it working. It says enter a line of text. There's my line of text. And for the fun of it, the program has an added feature just to enrich your life of printing the line of text I just entered backwards. So there it is printed backwards. Let's look at how the author printed it backwards. He created a function called reverse and used kind of a recursion step to reverse the order of the sentence that is stored. Yes. So the string I entered on the keyboard, which terminated in a return character or a new line, gets stored in an array called sentence. This was the size of the array, and the place I got the string from, because it could have been from a file, but I got it from a standard input. So that's how fgets work. Fgets works. This array called sentence I do have available to me to do something different with. Your author created this recursive reverse function to reverse the order. So he called it right here, passed the array sentence to it, just to prove to you that there was an array called sentence that could be passed to a function. But in reality, it would have been a whole lot easier just to use a for loop and reverse the order of the characters rather than using that recursive function there. But anyhow, the real point is I entered a bunch of characters on the keyboard which terminated in a new line, and provided I made enough space for it, and in this case I made 80 spaces for it, provided I made 80 spaces, my stream of characters is stored in an array called sentence. So that's what fgets does. Short example of what put character does. So I have a put character and I have the character L. When this part gets executed right here, L will be put to the screen, or the standard out, right? But put character also returns the integer value that corresponds to L, and in this case I've stored it in C, and just to prove that I printed C, and then what gets put on the screen is a 76. So the value of C was L, so L in decimal is a 76, and I can go back to that slide where I did the conversions. Capital L is a decimal 76. That's how it's stored in memory. It's actually stored as a hex value. No, it's actually stored as a binary value that corresponds to decimal 76. So that was an example for put character. Next I'll demo the function sprintf. This is like printf, so printf prints to the screen, your monitor, but sprintf prints it to an array, and later we'll get fprintf for a file. So this one prints it to an array. So right here I got a value for x, a value from I, for y from the user. I created an array s, and then the value of x went into s and y went into x, and it's actually an array. And when I print the array back out, I will see that yes, indeed, sprintf stored it into an array. Example of scanf. So I created an array s. it has two values in it, one value like this and one value like this. So I put those two values in the array, and it says it's a character array. Then I declared an int x and a double y, so I have a kind of an implied conversion going on, or I'm actually using. Oh, this should be interesting. We should look at the results just to make sure that the results are doing what we think. But anyway, the scanf reads the array S, and what it's doing is it's reading it and putting the value, each value from the array. One of them went into X and one of them went into Y. So it's reading instead of reading from the screen like our scanf function does, it's reading from this array. It reads until it comes to an end of file, and it stores where it's supposed to be stored according to this format specifier. Oh, so there's our casting operation. It says the first thing to read is an integer, decimal D, and the next thing to read is a double. So that's what it did. It read it as an integer and then read it as a double. Yes, indeed, if you run that program, you'll get an integer stored first and then a double stored second. So we talked about functions that you get out of the C-type library and the standard library. So now let's talk about functions that you get out of the string.h library. This whole chapter is really a survey of functions. I'm not going to expect you to memorize all of the functions that are here, but be aware that they're there so that you can use them should you need to. So when we talk about the string.h functions, they can broadly go into actually four different categories. Functions that do comparisons, functions that do manipulation, functions that do searching, and then there's functions that mess with moving things around in memory, which I should have written there. So let's look at the manipulating ones first. So these are things basically that, let's see, it's pretty self-explanatory really. Copies string 2 into array string 1. So there's an array. We'll go through some of these examples, not all of them. Copy characters, concatenate. We already talked about concatenate. I will do an example of concatenation, and then there's concatenate n of the characters. So example, here is my first example. This one is an example for using the string copy. So walking through this, I have a string declared by this array, or it's really an array of characters. Happy birthday to you. Always remember that there's a hidden /0 at the end, a hidden null escape sequence character there. And then I have two arrays defined right here that aren't initialized in any way, one with size 25 and one with size 15. So basically what I'm doing is calling the string copy function, and what it does is copy string x into string y. So y is, well, it's an array, right? So you copy the thing that's located in array x and put it into array y. So x is happy birthday to you. I'm copying what's x is and putting it into y, and that's what the function does. And this will be the result of doing that statement. Not real exciting, but yes, you can move arrays around. The next part of it is where you're going to copy only n of the characters, and in this case the amount is 15 minus 1. They're copying the first 14 characters of x into y, because when you do this it won't copy the null character. So when I do that, I counted the characters here. So the first 14 characters, which is 0 to 13, ends at y, and then there's a space right here, and the unimpressive results right here is that you get the string array happy birthday only because it's the first 14 letters. It does say to make the 14th letter be the null character so the string is proper. This actually can mess you up because right now the string is, if you don't put the null character at the end, the string is not proper, and the using a string expects to have a null character at the end. So you can have some errors if you didn't put the null character at the end. Later I'm going to show you a function where the null character gets put in for you when we're doing tokenizing. The other function I want to bring out is concatenation. This is one that I do want you to put into your memory what concatenation means. Concatenation is basically linking or joining things together in a series. This is just the English language definition right here, but it applies in the programming world. I already briefly showed it to you in a previous chapter, but let's do some very specific examples. It's kind of obvious, but you still have to know what the word concatenation and what the function is doing. So string 1 says happy with a space at the end, which I highlighted in yellow. String 2 is New Year, and then string 3 is the place where I'm going to put it. I gave myself 40 spaces and I initialized it with just blank, empty, null. And then here's the instruction to actually concatenate string 1 and string 2 together. So string concatenate string 1, string 2, and there's the function calling it. And when I do that, it prints it out, right? Happy New Year. Not kind of obvious, but still know what concatenation means. And then there's a version where you can concatenate only the first 6 characters. So I have an example doing that too, where I get the first 6 letters of string 1 and concatenate it into string 3. So that's what shows up. Here it is, this line of end of the answer right now. I take 6 letters, which is 1, 2, 3, 4, 5, and a null character, and I put it into string 3. So, and then the last one, just playing games where I'm now concatenating string 1 into string 3, which already has happy in it, so you get happy, happy New Year. The next category of functions in the string.h library are string comparisons. So string compare right here, compare string 1 with string 2. And then you can compare a certain number of letters, so there's the n in there to say you're comparing up to n characters. It says here in the definition the function returns 0, less than the 0, or greater than 0, depending on whether the string is equal to, less to, or greater than the other string. So how you're saying a string, how can it be equal to, or less than, or greater than? So here's what happens. I have a string right here. String 1 is the quick brown fox, and string 2 is the quick black fox. But each one of these characters is stored in ASCII code in your computer. So a capital T is a 54. I have this in decimal right now. No, I don't have it in hex because I can tell there's a B right here. That's hex. And so these are exactly equal until we get to this letter right here. And there's an R in one string and an L in the other string. Well, an R in ASCII translates to 7-2 in hex, and an L translates to 6C in hex. 7-2 is greater than 6C, so therefore string 1 is greater than string 2. And when I execute this command, my program will return a 1 to me. Here's another example of using it. It's a little bit different than the textbook example because I'm going to do the textbook example next. But this one I think is more straightforward. So string 1, string 2. Actually, this is the code that I just did the illustration for. So if string 1 or string 2, compare string 1 and string 2. If it's greater than 0, then I'll print string 1 is greater than string 2, which it is in this case. This is the, next is, actually I didn't do the example in the textbook. I decided that my example was more straightforward than the textbook example. But if you want to see more examples, you can see it in the textbook for string comparisons. Searching and related functions. So I've sort of summarized them here because it was a kind of a long list. But there's, even in the searching and related string functions, there's 2 categories. There's one category of functions that locates something in the string. Locates the first character in the string, locates the last of a certain character in the string, there locates a substring within the main string. Those are the type of functions that you can do with these particular searching and searching string functions. Notice these are the function prototypes being declared here. It's nice to see the function prototype because you know what kind of parameter is expected by the function, and then you know what the function is going to return. For example, in this one's I call it string character, but this locates the first occurrence of a character and it returns. The interesting thing here is that it returns a pointer. That is what is meant by locates within the string. And I'm going to have an example to illustrate that in a moment. So this is expecting to get a string and it's expecting to get a character passed to it. So you have a string and you're looking for the first occurrence of a character, and then the function is going to return a pointer to that character. So there is a pointer there for all of the functions that say locates, that has a pointer here in the function prototypes. So I'm going to do one of these. They're all kind of similar, and then this one down here is a little bit different. This one's called tokenizing a string, which I have a whole separate example for that. So I have that in a different color. So let's do some examples. So this particular example is an example of searching for the first incidence of a character within a string, and I said that it returns a pointer. So let's look at what this program is doing. I have a string, and the value of the string is this is a test. No problem. Character that I'm going to look for is an A. Another character that I might look for is a Z. And so there's a test right here, and this function call I think is a little bit interesting. So I'm going to do the function call where I'm looking for this particular character in the string. So my string is this is a test, and my character is an A, and I'm looking for A occurring in the string, but I have it embedded in an if statement. So I'm either going to return a pointer location to where that character is in the string, or I'm going to not find it and null is going to be returned. So that's why I say if string character is not equal to null, then I'm going to return the location where the string was found. And so it says A was found within, the way the program in your textbook is, this is from your textbook, I'm going to return a statement basically that says that A was found in, and then I'm going to repeat the string. But it didn't, this example from your textbook didn't illustrate to me the fact that you're returning a pointer. So I have a different example to illustrate that fact. And then there's an else statement. If the character wasn't found, then you're just going to make another statement. So that's okay, but this example didn't illustrate the fact that the function call actually returns a pointer or null if it doesn't find the character in the function or in the string. So let me show you this other example I have here, and this is again out of a book I occasionally reference, Beginning C 5th edition, which is a free PDF book online. You can search for it and you can find it by Ivor Horton. So I create a string, the quick brown fox. This is the string I'm going to search. I'm going to search for a letter Q in this string. And then I'm going to create a pointer that's just initialized to null because there's nothing stored in it right now. But I'm going to restore the result of searching this string. And I will store the result of searching this string in this pointer that I've set up right here. So then here's the function call itself. Look for that character Q in the string quick brown fox, and this is what it does. So it goes through the quick brown fox, and after executing this little piece of code, that code right there, then what I'm going to do is store the location of where the result was found in this variable called pgot character. This stores the address where the character is found, which will happen to be at the beginning of the string +4, 0, 1, 2, 3, 4. So an address will be stored here when you execute that code. The last section I'm going to cover in this textbook is about tokenizing a string. Tokenizing is a really important concept in programming. So big things that you got out of this chapter: concatenation, what that means, that there are all kinds of string functions that you can do, and tokenizing. So tokenizing is breaking the string into a series of tokens, but tokens can be words, for example. So you have a sequence of characters that are separated by delimiters. Delimiters are things like spaces, commas, semicolons. Those are called delimiters. And the program, what the function does is everything between delimiters is one token. So you can, for example, use this function to count words in a sentence, and the words are separated by spaces, and the space is the delimiter. You can have more than one delimiter. You can have a space, a comma, more than one that can be used. This has the dereferencing symbol as part of the function's prototype right here, and it says that calling this function is going to return a character. So let's see how this works. It's best to show tokenizing a string by an example. So this is an example out of your textbook, and I'm going to walk you through it because it's a little bit hard to understand. So I created a string, or an array of characters, called it unoriginally string. This is a sentence with 7 tokens. Why is it 7 tokens? Because each word is one of the tokens, and my delimiter is going to be a space. So if I count the words, 1, 2, 3, 4, 5, and 7 counts as a word because it's separated by delimiter. And so that's 6 and 7 tokens. So there are 7 things that are separated by delimiters, which is the space. This printf statement is just setting up for what I'm about to do. So now I'm going to call the string tokenize function. The thing I'm going to pass to it, the argument, is going to be a string. The array of characters I called string. So that sentence right there, actually it's the address of that sentence, right? I passed that whole string into the function, and then the thing that I want to be a delimiter, which in this case is a space. I could have several delimiters here. I could have space, comma, etc. I can have several of them here, but I'm just going to use a space for this example. Now this function returns something of data type character. That doesn't necessarily mean I'm returning a single character, which I'm not. It could be, but I'm not. But the data type will be character. Keep in mind that a string is a data type character. So even though this is a whole string of characters, its data type is a character. So that's what this string tokenize is going to do. It's going to return something of data type character. But actually, it's going to return a pointer to something of string type character. Okay, so one of the other interesting things about this tokenize is that just calling it once is not going to print out all of the results of it. So this is what we do. We say while the thing that I'm pointing at, so token pointer right here is a pointer, and it points to something that's the thing that's stored in the value that's stored in memory. So while the thing that I'm pulling out is not a null character, so while I am not at the end of the string, then I'm going to print whatever that thing is that I'm pointing to, which happens to be the value of the token. This is the value of the token. This is the pointer to it. So the value of what I'm pointing at. So one of the little things about this function that's kind of interesting is that as it pulls off this first token right here, because it's tokenizing it, it's going to pull off this first token right here, which is the word this. And this token by itself is a data type character. It's multiple characters together, which makes it a string, but at the end of the string you always have to have the /0. So the string tokenize function is going to attach /0 at the end of this token as it pulls this token off, in place of where this space would have been. So my first token that it will pull off is, maybe I should make some notes as I go through here. As I'm going through my while loop here, it says while the token that I get is not a null character, I'm going to print the token, whatever the token is. So the first time I go through this while loop, the token is a this, but the function will add, it's /0. This is going to be added to the end. So that makes this a complete string, right? You always get the /0 at the end. That's the first token that's pulled off. Make this a little bigger so you can see, because this is the result of executing this program right here. I'll make it bigger so you can see. The first token that gets pulled off is the word this, and you can't see it printed on the screen, but there is also the null at the end. But the next token, I have to go through the while loop to get the next token, because calling string tokenize only returns the first token. So I have to call string tokenize a second time to get the next token. But the next token is going to start with a null. It's the way the string tokenize works. It starts with the null character that was just added in, and I'm going to the next space. So this will get the next token, which will happen to be the word is, followed by the null character. So you go through, the string tokenize will go through and find each token until the next thing that it pulls off, it's using this null, I should say, it's using this null to know where to start to pull off the next token, until finally it's going to the end and it gets a null right from the start, and then it says I'm done, there's no more tokens. But it uses the fact that it had appended a null character here to know where to start for the next pulling off the next token. So one other little important thing to remember is that as you tokenize this sentence, it pulls off a token, it puts the escape sequence at the end of it, it uses this fact to find the next token until it gets to the token that's at the end of the whole sentence, and then it's done. But one thing that by doing this, by tokenizing it, you have lost the original string. So if your program has to do something with the original string again, then you need to preserve a copy of the original string with that. So sort of brings us to the very last section in this chapter, which is another section of string.h library functions. They are all having to do with memory functions, letting you to move, copy, and compare bytes in memory. So it's not just trying to move a character or find a character or compare a character. You're actually moving bytes around. You can read it if you want. We don't need this section for doing any of our homework problems. Be aware that it exists. So conclusion for this chapter. This chapter looked at additional character and string functions that are contained within these libraries that we can include with our programs. There are tons of them, as you saw. I feel like this video was really a survey of functions, and I didn't go through all of the functions because a lot of them are just self-explanatory. I just demoed examples of each. Be aware that they exist. You certainly don't have to memorize all these functions. Be aware that they exist. And so if you are doing something that has to manipulate a string or manipulate a character, uh, or find a character, you can know where to find them and look them up again. That's going to conclude this chapter. It's actually, in a way, a easier chapter. Well, definitely easier than our last chapter was. Bye now.